Thank you very much. Okay, so today I'm talking about a method to 3D print with supports. So I'm gonna go through kind of an explanation of why and what is our dream in 3D printing. So these are the overarching goals of our civil engineering, going high and expanding into spans. When you say 3D printing, you're promising to make use of form freedom and be able to produce something like these amazing structures. However, are we here yet? So reality is we're not even 3D printing to this level, if you want to say, neatness. So you cannot get such a neat structure like that, or even prefabricated. And even if you look at the bridges that we have made them segmental, post-tensioned them, and so on and so forth. So there is a lot to do from today to be able to go all the way to this applied on that scale. And to emphasize where I'm going, I would like to say that as civil engineers, we try to, hey, 3D printing, additive manufacturing is using this technology. Let's just switch the ink. So if it's centered laser, we do selective binder jetting. And if it's fusion deposition, well, we deposit, but something else that is extruded deposition. Great, but did we utilize as much the capabilities of additive manufacturing, or we actually tried to fit ourselves under something we saw? So that's what I'm trying to bring to your attention, and I believe this was shown before in the presentations that mimic the biology and just the previous presentations to my presentation. They show the benefit of going further into the challenge. For example, having two materials to be mixed at the nozzle. Mixing at the nozzle is a great challenge, but amazing you're doing it. So some extra step further is to try, for example, using a mix between 3D printing and some techniques like using flexible fabrication for molding, or actually 3D printing on the mold. So this is kind of mixing precast and 3D printing in one piece. So can we do better? What I developed about 3 years ago is a dual extruder 3D printer. Again, I'm mimicking something too, so I'm not reinventing the wheel. It's just the 3D print with support. But the key here is, can you make a support that is sustainable, not that expensive, and you can remove it easily, and it works with concrete? To be honest with you, my first idea was paraffin wax. And then I realized, okay, it's going to float on top of concrete. The density of paraffin is less than the density of water. And concrete is 2.5. So I will not be able to keep any opening if I want. It's going to float up. So I switched to clay, and that's what I will quickly show. So what I do here is I 3D print clay. This is clay, the inner is clay, and inside is underlayment that you buy from Lowe's. So this is very flowable. You pour it. So this is simply doing printing of the shell, if you want to say, or the formwork, and then pouring concrete. So if the concrete has any better rheology than an underlayment, it's a gain. But if it's even an underlayment, you can do it. You can still do it. This is, for example, ultra high performance concrete with the clay floating on its surface. If you look here, These are about 4 or 5 layers, I don't recall exactly, co-printed with the pouring of UHPC, and nothing is floating up nor floating down, because the density of clay is pretty close to the density of UHPC. So you can print them on top of each other. Didn't stop there. In the next slide, I will show you the finished product. But why clay? Well, clay naturally shrinks, so you don't need a lot of effort to take it out. It already shrinks and it's gonna crack. You either remove it by mechanical effort or just water jet it, and you end up with your cast sample in this case. And then the good thing is you take this, just add water, and you have your material back. You have your support back. So instead of paying a big amount of money and losing the mold, you know, in precast, for example, is that the challenge is to form the mold and to cut the mold, and then the mold degrades. Now you have a mold that you can recycle and reuse multiple times, as many times as you want. So this is the UHPC sample. You can see that after I printed that X shape, I was able to print a perimeter around, and I was able to cast concrete on top, and nothing floats up. Of course, it's not a perfect smooth surface, but that's what I was able to do with a desktop internally designed and manufactured 3D printer. Other examples, these are, again, clay was printed here, then cast, print on top of the cast, and then cast. So as you can see, you can make holes, you can make openings, and here you can make overhangs, but it doesn't look that nice. However, I do have openings, I do have overhangs. And the main reason that these shapes are not that nice is the capability of the printer. At that point, I just bought a clay extruder, and the filament size, as you can see, is pretty close to the dimensions of the sample. If I'm printing something bigger and I have multiple layers, you will not see that very discrete layers in the system. So some animations. Another help that you can get from the use of support is actually to support your reinforcement. We have a big problem in 3D printing when we try to add reinforcement the regular way. Of course, there are a lot of efforts that we can see now that are trying to develop 3D printing compatible reinforcement methods. But if you want to do a portal frame with regular reinforcement, well, you need to support the reinforcement while you are casting. So here, I was very generous with the amount of clay I used, but that was the one test. And then you could use robotics, my hands, to place the reinforcement and then cast. So here is the robot putting the hands, putting the reinforcement, and then that's the final shape, and here is underlayment. So you can see it's 100% flowable. It's actually self-consolidating. But then this is the final cast sample, and this is me taking it apart. After just one day, you can just take apart basically the material. And this material was again recycled and reused. So with optimization, with adding sand, or this was like pure clay. But as you know, at 20% replacement, 25% replacement, up to 25 to 20% only clay in a clay shale or a clay sand mixture, you still have the cohesion or the mechanical behavior of a clay or a clay-like soil. So you can still have the support behavior of it. And this is the finished structure. This is a conceptual idea. I'm not saying I'm going to support the 3D printing up to 10 floors. Not realistic. There is no way you can tolerate such a pressure. But the idea here is kind of a replacement of the natural or traditional precast with pre-made molds with an in situ molding and reuse of the molding materials. With this, my closing remarks are actually kind of a list of what I think what I presented could help in the main challenges we have in 3D printing. So from a sustainability point of view, we already have developed many, many mixes that are better in terms of carbon footprint, and now we're challenged to make them 3D printable. If I enable you to cast them, then we are making use of all that technology without having to switch it. And for example, we had speakers in the first session talking about if you want to make smaller dimensions, for example, then you will have to have an increased amount of the binder. If you want to use finer aggregate, it's a problem because of its surface area. You need to use more binder. But what I'm saying is that you have the mold, you can cast regular concrete. You could think of longer term durability. So the idea on the sustainability here is I'm giving you a chance to produce a structure with the current concrete, the best concrete that you can get. From the scale up, if you can print the molds in clay, extrudes easier, it's more cohesive, so you can have a speed up of the print. It's not as speedy as regular 3D printing, but we have also the buildability and all of these issues. And the form freedom, of course, having the ability to support is definitely much better form freedom compared to regular 3D printing or trying to cantilever a paste as you print it. With this, I'd like to thank you very much, and I'm happy to answer questions.